Hi, everyone. So, I'm going to create a little series of videos here. And so, it is going to be best if you watch these in order. I'm going to try to break down our fundamental trig identities into like bite sized chunks with a couple of different examples built in. This video is going to focus solely on the identities, what they are, and what makes them an identity. So we have three different types of identities that we've learned so far, and I do phrase it that way on purpose because there are going to be more identities to come. But so far, we've learned about reciprocal identities, quotient identities, and then the Pythagorean identities. Now, a lot of these identities come from the unit circle, and we kind of built how they were derived from that unit circle, specifically the Pythagorean identities. I'm going to write down the ones that it's most important to have memorized. Now, there are more than this. I want that to be very clear. There are more than this, but we're going to start with our reciprocal identities. So, a reciprocal is when you flip a fraction over. So, when you flip a fraction over, that's what gives you a reciprocal, or that is what reciprocalizing means to do. And another way to write that is 1 over. So if you ever see 1 over something, that means that you're flipping your fraction. So the first trig identity that it would be really wise to just have memorized is cosecant of x is the same thing as 1 over sine of x, which means that sine of x is the same thing as 1 over cosecant of x. And the 1 over sine of x just means take your fraction and flip it. So cosecant of x is the same thing as 1 over sine of x. Okay, the next reciprocal identity would be secant of x. Secant of x is the same thing as 1 over cosine of x, which in turn means that cosine of x is the same thing as 1 over secant of x. These are our most common reciprocal identities. It's not all of them, but these are the most common reciprocal identities. And if you've got these in your head and you know that cosecant of x is the same thing as 1 over sine, or sine is the same thing as 1 over cosecant, then all of the sudden, these identities become so much easier. So those are the reciprocal identities. Now, my favorite identities are the quotient identities. The quotient identities tell us about tangent and cotangent. So tangent is the same thing as sine divided by cosine. Now, I want to pause, I want to stop for a second and remind us what an identity is. An identity is an equation that is always true. And so if you were to graph these things, no matter what, you're going to get exactly the same curve each time. So I'm going to take a moment and I want to show you that these are identities. So the one that we just talked about was tangent of x, and tangent of x is the same thing as sine over cosine. If you look, these graphs are exactly the same. That's what makes it an identity. Now, later on, we are going to start solving trig equations. Trig equations are things that are not always true. So if I said tangent of x equals 1, that's not always true. It's only true at certain values. That's not an identity. That's what we call a conditional equation. Now, the other one that we said was that cosecant of x is the same thing as 1 over sine of x. If you look, again, these graphs line up exactly. It doesn't matter where you're at on the graph, all of the points are exactly the same. That's what makes it an identity. Okay, so tangent of x is sine over cosine. Cotangent of x, kind of fun, cotangent of x is the reciprocal of tangent. So because it's the reciprocal of tangent, all you have to do is flip your fraction. So it's cosine over sine. And again, we could do the same thing in Desmos where we can type in cotangent of x and we can type in cosine over sine, and you're going to see that they overlap. They're exactly the same graph. All right, we've got a few more identities, and I'm going to tell you right now, if you have these identities memorized, all of these questions become so much easier. It's just so much more clear. So our last set of identities are the Pythagorean identities. And as their name would suggest, they are derived from the Pythagorean theorem. And so the Pythagorean theorem is a squared plus b squared equals c squared. We've been working on that since what? 6th or 7th grade. Now, the Pythagorean identities put in some sines and cosines, and really they're derived from the unit circle. And we talked a lot about that in class, where the opposite side is sine, the adjacent side is cosine, and then the radius of the unit circle is always 1. So if you've got the opposite side, which is sine, and you have the adjacent side, which is cosine, and the radius, which is 1, then sine squared plus cosine squared equals 1. And that is our first Pythagorean identity. Now, I do want to talk a little bit about the notation here. What you notice is that the sine squared of x, the squared is written in between the sine and the x. This is the same thing as sine of x squared. You're squaring the entire function. We don't put the squared, we do not write it like this, because that is just squaring the x. And we don't want to just square the x. We want to square the entire function. And so that's something that I will show you in Desmos as well. So you can type it in like this, sine squared of x. You can type it in sine of x squared. You cannot type it in like that. So that is a very different function. That is the same as this, sine of x squared. So the red and the blue lines, those are not the same thing. So you can write it like this or like that. When we get to things like sine of the 4th power, you can't write sine to the 4th power like this. That's how you'd write it on your paper. But if you're trying to plug it into Desmos, Desmos just hasn't been coded to handle that yet. So if you're trying to type it into Desmos, you're going to write it like sine of x to the 4th power, like that. All right. Since we're here, sine squared of x plus cosine squared of x, what we just said is it always equals 1. And there's your graph. It's always equal to 1. If you look at that y value, it's always equal to 1. Now, using some algebra, using what we know about algebra, we can rearrange this in a few different ways. And we want to be able to recognize all of those different ways. If we can recognize those different ways, again, just the pre-calculus becomes so much easier. And that does transfer into calculus as well, because we do use some trig identities in calculus. Not like a copious amount, but there is some. So I could rearrange this for cosine squared. And if I were to rearrange this for cosine squared, all I would have to do is subtract that sine squared of x. So cosine squared of x is the same thing as 1 minus sine squared of x. And again, you could type those into Desmos to prove that they really are the same thing. So cosine squared of x looks like this. 1 minus sine squared of x looks like that. And what you'll notice is they're exactly the same graph. Okay, so there are a few more Pythagorean identities as well. Sine squared of x is the same thing as 1 minus cosine squared of x. So all of those are Pythagorean identities, but we have more of them. Because this right here really is the basis of all of these Pythagorean identities, and we can apply algebra in so many different ways, you could alter this by dividing everything by cosine. You could alter this by dividing everything by sine. You could divide by other things as well, but sine and cosine are kind of the main ones. So if I took this function here, sine squared of x plus cosine squared of x equals 1, and I applied algebra's golden rule, and I divide everything by, let's say, sine squared of x, algebra's golden rule is if I divide this side by sine squared of x, I must also divide this side by sine squared of x. Then I'm going to look at each component. Sine squared divided by sine squared is 1. Cosine squared divided by sine squared, well, we just learned this quotient identity, and cosine divided by sine is cotangent. So naturally, cosine squared divided by sine squared would be cotangent squared. And we just learned a reciprocal identity. 1 over sine is cosecant of x, so naturally 1 over sine squared would be cosecant squared of x. And there's another Pythagorean identity. Now we could do that same thing and divide everything by cosine instead. So we would start right here. Our quotient identities tell us that sine over cosine is tangent. So naturally speaking, sine squared over cosine squared would be tangent squared. And cosine squared over cosine squared would be 1. And 1 over cosine squared, well, 1 over cosine is secant. So 1 over cosine squared would be secant squared. So those are that's not all of our identities. Those are the identities that we really want to know. We want to know them backwards, forwards, left, right, up, down. We want to be able to recognize them in any sense. So this is just the first episode in many for this series. I'm just going to title this series Fundamental Trig Identities. And I hope that this helped you understand those identities.